Good morning. This is Neil Paulimus. I'm Director of Development at Statgraphics Centurion, and I'd like to talk to you today about our newest version, version 17.2. The most important new feature in this version is an interface to the R language. R is a language and environment for statistical computing and graphics. It's widely used by statisticians to develop new statistical methods. There are hundreds, maybe even thousands of libraries available for R which perform many types of analyses. And one of the best things about R is it's free. Why interface to R? Well, there are several reasons. First, it gives users access to new techniques which we've not yet included in Statgraphics. It also lets statisticians code their own routines and access them from Statgraphics as if they were part of our package. The interface provides an interactive environment similar to the execute window which was available in Statgraphics for DOS. Those of you who've used Statgraphics since the DOS days will remember that the early versions of Statgraphics were written in APL. That allowed us to provide an execute window quite similar to the R console, in which individual commands could be executed. What are the features of the Statgraphics R interface? First, we make it easy for you to exchange data between Statgraphics and R. You can load your data into Statgraphics and, using a simple dialog box, have that data transferred over to R. Secondly, you can run R commands on data stored in the Statgraphics databook. You can retrieve output from R once you've run procedures there and save it in the Statgraphics stat log. And finally, you can save R scripts in StatFolios for later reuse. If you'd like to use the new interface to R, the first thing you need to do is install R on your computer. You can do that free of charge and quite easily by going to the link that I display on this screen. Once you get to the page, select Download R, pick a mirror site located near you, and follow the instructions. Once the installation is complete, an icon similar to that shown here, the big R, will be placed on your desktop. You right-click on the icon and select Run as Administrator to load the R console. Clicking on the R icon loads a window containing the R console. The R console is a place where you can type commands and immediately have them executed. For example, let's create a variable called x by typing x arrow, which you can create with a less than symbol followed by a dash, C for combine, and then 5 data values, 10, 20, 30, 40, and 50. When I press return, the variable x is created, and R then waits for me to type something else. There's a nice command in R called summary, and if I type summary parentheses x, it'll give me a 5-number summary of the data: the min, the max, the median, and the 2 quartiles. You should note as you're working here that R is case sensitive. If I create the variable x as a capital X, I need to use a capital X in all the additional commands. There are other functions built in, such as mean, that will calculate the mean of a vector. There's a function called SD, which will calculate the standard deviation of a vector. I can now create a vector of normal scores, let's call it Z, by saying Z is assigned x minus x bar divided by S. If you'd like to see Z, I can just type its name, and the 5 normalized values of x will be returned for me. There's a basic plot command in R, where if I type plot parentheses Z and hit return, a simple scatter plot will be created. There are 4 additional commands that we need to type into the R console while we're here. These only have to be typed once, but set up the interface between Statgraphics and R. Type these 4 commands in sequence. They install 2 packages: the pandoc package, which exchanges output between R and Statgraphics, and the seasonal package, which runs the X13 seasonal adjustment procedure that I'm about to demonstrate for you. As an example of using the Statgraphics to R interface, I'm going to show you an example which uses the X13 ARIMA seats seasonal adjustment package. X13 ARIMA seats is the current method used by the U.S. Census Bureau and many other agencies for seasonally adjusting time series data. X13 ARIMA seats has more options than the seasonal adjustment procedure currently in Statgraphics Centurion. We're going to use the R interface to load data into Statgraphics, pass it to R, seasonally adjust the data in R using X13 ARIMA seats, and then retrieve the seasonally adjusted data and put it back into the Statgraphics data book. I've loaded Statgraphics Centurion version 17.2, and I'm now going to open up a data file that has some time series data that I'd like to apply a seasonal adjustment to. To do this, I'll go to File, Recent Data Files, and open a data file called Golden Gate. This is data quantifying traffic on a monthly basis across the Golden Gate Bridge in San Francisco. It begins in January 1968. To plot the data, I'll select Plot, Scatter Plots, XY Plot, plot traffic as a function of month. I'll then use Pane Options to connect up the points with the lines, and you can see that it's quite an interesting time series. It's a highly seasonal time series. Traffic is much higher in the summertime than in the wintertime on the Golden Gate Bridge. You can also see the effect of 2 oil embargoes that occurred, where long lines formed at gasoline stations in the United States. That had a significant effect on long-term traffic on the bridge. I'm now going to take the data from the Golden Gate Bridge and pass it to R so I can do a seasonal adjustment. To do this, I'll go to the Tools menu in Statgraphics, and you'll see 2 new menu items: Interface to R, Exchange Data, and Interface to R, Execute Script. Selecting Exchange Data will open up a dialog box that I can use to control data that I pass back and forth between Statgraphics and R. At the top of the dialog box is an edit field in which I've previously typed the path to R, associated with the icon that was created on my desktop when I installed R. If I now go ahead and press load, it will load the R console for me, which I'll temporarily minimize. To pass the Golden Gate Bridge data to R, I now need to go through 5 steps. The first step is to specify the name of a R data frame that I'd like to create. In R, a data frame is a rectangular collection of data where variables define the columns and observations define the rows. I'm going to ask for a data frame called Bridge to be created. I can also tell it, if I wish, that string variables, character variables in Statgraphics should be converted to factors when they're loaded into R. Factors are a special type of data structure in R used in procedures such as the analysis of variance. If I simply want to use the strings as labels, I won't check this box. Step 2, I'll press Select Columns. And now I need to indicate to the program what columns in my data sheet are to be passed to R. If I want all the columns, I can simply press Select All and then OK, or I can select just the columns that I wish. The third step is where I'll press the Export button. This actually created a CSV file containing that data, which will be loaded into R. For step 4, I'll press the Copy button, which takes the command shown to its right and puts it on the Windows clipboard. Once on the clipboard, I can then go back to the R console, press Ctrl V, which will put the string into the console, and then when I press Enter, that CSV file that I've created will be read and the data assigned to Bridge. The final step, going back to Statgraphics, is to push the second Copy button, which copies a simple command structure of Bridge, which when I execute it in R will show me the contents of Bridge. You can see that Bridge here is a data frame. It contains 168 observations on each of 2 variables. The month variable is character, and you can see the strings. There are 168 strings indicating the date corresponding to each row in that data structure, and traffic is numeric, containing the actual traffic counts. Now that I have the data in R, I can apply the seasonal adjustment procedure. The first thing I need to do, however, is create a time series. A time series is a special data structure in R which contains not only the data but also information such as, is it monthly, is it yearly, is it quarterly, when did it start, and so forth. To create a time series, I'm going to type T is assigned TS, open parentheses. TS is actually a function that will create the time series for me. The first argument of TS is the name of the vector containing the data. Now, in order to select a column from a data frame, you have to type the name of the data frame, a $, and then the name of the column. So I've typed here bridge $traffic to indicate the numeric variable that I want to convert to a time series. I'll then type a comma and define start. I'm going to say here start equals C, combine 1968, 1. Okay, and TS will then figure that the first observation in that traffic data starts in January 1968. Then finally I'll type another column, and then frequency equals 12, which will indicate to the program that it's time series data. I can examine the structure of my time series by typing STRT, and you can see that R indicates that it is a time series ranging from 1968 to 1982. Now, to apply the X13 ARIMA seats seasonal adjustment procedure, the first thing I need to do is load the library seasonal. You may remember that when we first went into the R console, we installed a package called seasonal. In order to use it, I now need to indicate that I want that library. To actually perform the seasonal adjustment, we'll use a function called seas, S-E-A-S. And all I need to do is give seas the name of my time series, and it will perform this seasonal adjustment. Now, there are lots of other options to seas that you can use to override the defaults, but if you just give it the time series, it will perform the X13 ARIMA seats seasonal adjustment using the most commonly selected procedures. Now, if you'd like to see the result, I can use the plot function. And in this case, if I tell it to plot $$ data, we'll see a plot with 6 components to it. You can see a window it has opened up here. It contains in the upper left the seasonally adjusted data. In the middle left, the estimated seasonal effects. A second plot of the seasonally adjusted data at the bottom left. The estimated trend is plotted at the top right. The irregular or residual component in the middle right. And again, the adjustments that were applied on the bottom right. One more thing I want to do so that I can pass this data back to Statgraphics is now create a second data frame called results. I'm going to type results is assigned data.frame open parens $$ data. That will take the results that have been plotted here, create a data frame that can then be passed back to Statgraphics. And to see the structure of that, I'll type str results, and you can see that results is now a data frame, 168 observations on each of 6 variables: final, seasonal, seasonal adjustment, trend, irregular, adjustment factor, which are the 6 components that were plotted when we plotted $$ data. The last thing I want to do as part of this example is now go and get those results that I put in an R data frame and import them back into Statgraphics. Going back to the Exchange Data dialog box, you'll see a section at the bottom for importing data from R. There are 4 steps. In step 1, you type the name of the R data frame that you want to pull back into Statgraphics. In this case, it is results, which is the default that I usually use to pull things back. Step 2, specify a temporary file to be created. Not much work to do here. It's going to automatically pick a simple file name that should be good most of the time. Step 3 is to copy to the Windows clipboard a command that will actually write the results to a CSV file. Once that's put on the Windows clipboard, I'll go back to R, do a Control V, and it's now created a CSV file that I can read back into Statgraphics. Finally, I'll go back to Statgraphics, go to step 4, select the data sheet where I want the results to go, and push import. That went out, read the file I'd created, and now if I close the dialog box, go back to the data book, you'll see in tab B it's read the results from R, the 6 columns that were in that results data frame, which I can then use in any way I want. The final thing I'll do is go back to my XY plot, and on the input dialog box, instead of putting traffic, I'll now ask for the final seasonally adjusted data, and you can see the result of applying the X13 ARIMA seats procedure to the Golden Gate Bridge data. It's taken out the significant seasonality but left behind the trend and the unusual irregular values. The exchange data option that I've just showed you makes it easy to pass data back and forth between Statgraphics and R. This is very helpful when you want to apply R in an interactive manner. You want to pass data to R, run various R commands, and potentially pass some results back. But what if you wish to save a set of R commands so you can use them again later? The solution to that is to use the second item on the Tools menu, Execute Script. Execute Script lets you store R commands in a StatFolio so that you can later rerun them. I've now started a fresh session to show you how to create a set of commands and store them in a StatFolio. To begin, I'm going to open up again the Golden Gate Bridge data file. Now I'm going to go to the Tools menu, and this time select Interface to R, Execute Script. The first dialog box that comes up asks me which columns I wish to pass to R, and I'll select in this case month and traffic. There's also a standard select field, so you can pick a subset of the observations in the file if you want to. When you push OK, a second dialog box will open up. This is where you actually control the script. The first thing you need to specify is the path to R. Same path that we've been using before. The second thing to specify is information about the R data frame that you want to create. And I'm going to tell it I'd like it to create a data frame called Bridge. As before, I can tell it to please save character data as factors if I wish to. I can also tell it to completely remove any unselected rows. That corresponds to if I used the select field on the data input dialog box, any rows that were not selected. In the R script section, I'll need to first define the width and height of any graphs that R is going to create. I'm going to set those in this case both to be 9 inches. We also specify the number of seconds for the timeout. The timeout allows Statgraphics to continue after a certain length of time, even if R has not responded. Here you want to put a number big enough to let R do whatever procedures it needs to do, but not so long that Statgraphics will sit there forever waiting for R to give it back output in case R fails. In the big edit field, you place the commands that you wish R to perform. Now, I've saved the commands that we ran previously in Notepad. I'm now going to take that sequence of commands and copy and paste them into this field. Those are the commands that we individually typed into R previously, but we're now going to have them automatically executed. In the bottom section where it says imported data, I can specify the name of a CSV file that I wish to read into Statgraphics. Okay, and I'm going to take this path right here, c:/temp/r results.csv, and type it into the imported data field. As in the previous exchange data procedure, I also need to tell it where I want to put the data, the results of the analysis, in this case into B, and also tell it whether it may delete any existing data already in that data sheet. If I now press OK, it'll come up with the standard tables and graphs dialog box. In this case, there are two tabular panes that can be created. One called Analysis Summary, which has the output created by R. A second, Messages from R, which will show you any messages that R sends back, including error messages if one of those commands was invalid. When I press OK, Statgraphics will go out, load R quietly. You won't see any indication that it actually did load R, but it did. Have R execute the commands, have R create a file with the output, read the output back into Statgraphics, and have it displayed in a standard Statgraphics analysis window. And you can see here that R took the various commands that I gave it, did the seasonal adjustment, plotted the data, and created the results frame. I now have the output from the analysis in my interface to R window, and if I go to Datasheet B, you'll see that it also read the data back into the datasheet. Having done all this, I can now ask it to save the StatFolio, and I might have it save my R script, and then later on, if I wish, I can come back, open up that StatFolio again, and it will automatically call R, have it do the analysis, and give me back the results. The new interface to R we've added to Statgraphics Centurion version 17.2 will give Statgraphics users access to new techniques as they are developed. If you're not familiar with R, a good reference is R in Action, Data Analysis and Graphics with R. We look forward to hearing from you about your experiences with Statgraphics and R.